All right. So without further ado, I think a lot of you are already familiar with 88 Tuition style. You may have been with us for a few years. Some of you may have just joined us. Even then, you can be familiar with our style quite quickly by listening to our recorded videos online or even attending a live class like today. Okay, our master class here is for us to have an interactive session so that you guys have seen me on screen before, but were never able to speak to me. However, here you can. And right now your mic is all open, so and it's very quiet. So I'm fine with that, so that we can just talk like it's in a classroom. You can talk, I can hear. But if it becomes too noisy and people are talking unnecessarily and there's somebody talking in the background, then I just have to click one button called mute all and everything will be gone. You only hear me, just like how I threw the pen away. So let's see how this works out for the next 10 minutes. And then we'll figure it out. If you want to make noise, eat, cough, sneeze, just mute yourself. That's fine, right? All of you are in control of your own computer, and it's just a click away. Press the mute button right now if you think your environment will be noisy. It's fine. Okay, that's better, so that you can mute and unmute at any time, right? But if I use the control, then it's very hard for you to mute and unmute at any time. So that's worse. So we don't want a worse situation. We want a good situation. We want a good situation. All of you be smart about it and just say, I want to mute myself. Okay, so go mute yourself. A glass containing a block of ice and some water was placed in a room. The room temperature is 28 degrees. So I'm going to write it down here because this is the room. And then there's ice, there's water. Why is it both at 0 degrees? How many of you can understand why, although it's a solid here and it's a liquid here, but then they are same temperature? I thought liquid must be warmer, solid must be colder. Anybody want to answer that question?
Because both of them are at 0 degrees.
Yes, because I'm looking for this word. I'm looking for a special word. It's called, who can tell me the word? It's not here.
Melting.
Yes, wonderful. What's your name? When a process called melting is taking place, it's a process, a special process. All temperatures stand still. It will only happen at the melting point. What is the melting point of ice?
Dr. Ali, you're lagging.
How come?
I don't know. Just now when you talk, it's like I can't hear what you're saying.
Yeah.
But I can recognize it's your voice, just that it's like.
Yeah, I know. There was 1 second. I think there was some issue. I think the rest of you are okay, right? Okay, if there's ever an issue again, you can point it out. So now let's see. Melting point, because it is at a point, hence it happens at a point. Hence you can have liquid state and solid state at the same temperature at the same point because of the process that's happening. Your ice is melting. So there must be some water and some ice, some water and some ice, some water and some ice, until there's no more ice. When there's no more ice, then it's full of what? No more ice, full of water only. Can you see? I'm drawing water only left. Now, there's no need to be at 0 degrees anymore. Then you'll change to 1 degrees, then 2 degrees, then 3 degrees. Then water will keep warming up because the outside temperature is 28 degrees. So there is a heat transfer between the water and the outside. So they will try to gain heat. Who's gaining heat?
The water.
Correct. Because it's cold. It's cold water. Who agree 1 degree water is cold? So is there a hot body around there to gain heat? Yes. This is just like when you touch your mommy, your brother, your sister, right? Sometimes when you touch the other person's hand, one person feels warmer, at the same time the other person feels colder. You'll be like, hey, why your hand so cold? Then the other person says, hey, why your hand so warm? So both of you are touching each other. There's a heat transfer from the hotter body to the colder body. Hence, the body from which the heat leaves will feel cooler. The body that receives the heat will feel warmer. That's all. Simple. There'll always be heat transfer between two bodies. So now the two body here is water and room. Water is 1 degrees, 2 degrees, 3 degrees. Room is 28 degrees. So there will be a heat transfer. One will gain, one will lose. Come to a point where they reach the same temperature. That's why when you go out and come back, your water is not so cold anymore. Your Coke that was cold when you bought it isn't cold anymore. You'll be like, ee, what is this? This Coke not so cold. I don't like this Coke, or I don't like this orange juice. So cold drink can become warm. Same for hot drink. You have coffee, tea, you buy, you sit down there for 20 minutes. Hey, why this tea not hot anymore? Yucks, I don't like it. Because there's a heat transfer between, okay? Heat transfer between the two bodies, okay? Okay, so let's answer the question. Since I've explained enough, let's answer the question. Okay, we have 30 people in here. Only 25 answered. About 5 more can answer. Okay, but I can't give the entire day for you to answer. So I'm sure you can see how the class has answered, with the majority answering C. How about the rest of the answer? So let's look at C first, see whether it matches the question or not. Okay, which one of the following is correct when the water and ice were at?
Why is it number C?
Is it C? Let's check. The ice will melt as it gains heat from the room. The ice will not melt as it remains at 0 degrees. No, this is wrong. It will melt. So it will melt.
A is wrong, B is wrong.
The ice will not melt as it did not gain heat. It is gaining heat.
It's wrong also, B is also wrong.
The ice will melt as it gains heat from the water.
It's also
The
wrong.
water is what temperature? 0.
0.
Yeah. So how can it gain from the water? It's gaining from the 28 degrees.
2.
Yes. So answer is C. Got it? So if you look at the diagram on the left in red color, you can see 0 degree, 0 degree, 28 degree. So both ice and water are gaining heat from the 28 degree, not from each other. Okay. Both of them are at 0 degrees. The table shows the melting point and boiling point of two substances. Okay. So you need to figure out what is melting point, boiling point. Always like to have. This is, am I right? If I draw this, can you straight away know what is it correct? Like that? Is it correct? Like that, correct or not? If I draw it,
Yes, it's correct.
I cannot even see.
yeah, from a solid, you want to become liquid, it will happen at the melting point. From a liquid, it become boiling to gas, it become happen at the boiling point. So,
But why? Yeah. Okay.
state of substance P at 17 degrees.
Why is it second question?
Okay, so now you need to work it out. Huh? How many of you?
Yeah, but why is it not on the second question?
Okay, let's figure out
Yeah, second
what's the
question.
answer. Okay, are you ready to give me your answer? It's needs a bit of thinking. That's why I say you need like paper and pen to write it down.
Gas. P must be a gas.
This is P,
But why is it not on the
this is Q. At 17 degrees, it's only 17 and 45,
This
right?
one is solid gas. Okay, solid gas, liquid gas A. But why is it not on the second question? I don't know. Teacher.
So at 35 degrees, it becomes liquid. At 340 degrees, it becomes gas. Okay.
There's nothing here.
So you can see my workings. If you can understand my workings. Okay, this one is liquid. Sorry.
There's nothing.
Solid become liquid here at this point. This one boiling point, right? So liquid will become gas.
No.
So can we circle already? For P at 17 degrees is liquid.
The
At
liquid
450
will
degrees is-
evaporate.
Yes, like that. Now we look at Q. At 17 degrees is a solid. At 450 degrees is a gas already. Now, which one has the 4 circles? Answer is, okay, so this is how you do it. You need proper working. Where is the proper working actually? Right here, where I put the big star. Because I can circle the two temperatures there, 6 and 35, to say that is the temperature at which it goes from solid to liquid. Anything before that, it is a solid. So here, this one is
Yeah, but how come there is
solid,
nothing?
this one is liquid, this one is gas. Because they already passed the boiling point. 450 already passed the 270 and 340. They already become gas at 450 degrees. They are already gaseous state. So that's why answer is this A. Okay, those of you who are trying to catch up on what I'm doing, reason is you are slow is because 1, you never tried before. 2 is you are not listening carefully to my explanation. So if you need another round of hearing this, you just have to wait for the recorded lesson and watch the video again. You will understand. But before you watch the video again, I will highly encourage you to perform the exercise first, like do the worksheet first. Okay. Now, this is an interesting question. Now, in PSLE, you are bound to meet with questions that you may have never encountered before in your life. That's the whole purpose. Nobody wants to give you a question that you have seen. Then that means that you will do based on your memory than your knowledge. So, in this case, we have Mandy who's heating up a beaker of water until it reached the boiling point. Boiling point for water is 100 degrees Celsius because it's water. Then remove the beaker from the heat source and place the beaker of water in a well ventilated room. So she just removed the beaker and she just placed it over there. And there is water over there. And its start temperature is 100 degrees, right? Because she just boiled it. She took the note of changes in the temperature of water in the beaker for 20 minutes and plotted the graph with the values taken. So do you think the temperature will go down or go up?
Go up.
Go up. To get hotter and hotter. Because now it's not on the heat source
It will
anymore.
remain the same.